We are going to apply what you know about quadratic equations and how to solve them to real-world scenarios. Quadratic equations model projectiles and any thrown objects as well as falling objects. Skydivers use them to determine when they need to open their parachute. Businesses use them to maximize their revenue or money earned as well as profit. Satellites and electrical circuits are also modeled by quadratic equations, and so you have those to thank for your cell phone, your TV, and your internet. Before we begin, let's remember what the three forms of the quadratic equation reveal. Standard form reveals our y-intercept, factored form reveals our x-intercepts, and the vertex form reveals the vertex, and therefore the maximum or the minimum of the parabola. Your frisbee got stuck in a tree. You use a slingshot to launch a rock vertically into the air to try to free the frisbee. The rock is launched with an initial vertical velocity or speed of 63 feet per second. The first thing we need to do is model our scenario. This function models the height of the rock over the ground in feet, t seconds after launch. -16 is how we show the impact of gravity on Earth. The +63 is your velocity, and the +4 is your y-intercept because you were holding the rock when you threw it or used your slingshot. If we graph our quadratic equation, we can see a lot of helpful information. We can see the maximum of the parabola as well as how long the rock is in the air. Some questions we might ask are, what does the 4 represent in the function? What is the height of the rock 1 second after launch? Looking at the graph, I can see that the height is a little bit over 50 feet. When will the rock hit the ground? I can see that when time is 4, the height is 0. What is the maximum height your rock will reach? Well, it looks like our vertex is around 2 seconds, and the maximum height is slightly over 65 feet. If your frisbee is 35 feet from the ground, will you hit it? If I draw a vertical line at y equals 35, we can see that our rock will cross 35 feet in height 2 times. But let's say we don't have graphing technology. We want to use this equation to answer those same questions without a graph. First, what does the 4 represent in the function? The 4 is our y-intercept, and that is because if we are on the y-axis, then we know that x equals 0. Substituting 0 into our equation cancels out our quadratic and linear terms, and we get a height of 0 at time 0 equals 4 feet. You are holding the rock at a height of 4 feet when you use your slingshot. What is the height of the rock 1 second after launch? We can use the same methodology. 1 second is an interval of time, so we substitute 1 into our equation for t. The height at time of 1 second is 51 feet. When will the rock hit the ground? The rock will hit the ground when the height is 0. So now we have to substitute 0 in for h of t. At this point, we can solve the quadratic equation using any of the methods we've learned. Given these numbers, the quadratic formula is the easiest and most efficient method to use, so I substitute my values into the formula. I remember that a negative times a negative is a positive. I simplify this, and we get that the rock will hit the ground at either t equals -0.0625 or t equals 4. Negative time is not a viable solution in this scenario, so we know the rock will hit the ground at a time of 4 seconds. What is the maximum height your rock will reach? We could convert our equation into vertex form by factoring out a -16. Or we could remember that the line of symmetry is halfway between the x-intercepts. So we can find the distance from the line of symmetry to the x-intercepts. To find this distance, I average my two x-intercepts. 4 minus a negative is the same as 4 plus 0.0625 divided by 2, and we round that to 2. 2 is the distance from the line of symmetry to the x-intercepts, so I can subtract 2 from 4 to find the x value of my vertex. 4 minus the distance to the line of symmetry equals 2, so the vertex is at a time of t equals 2. To find my maximum height, I substitute 2 into my equation, and that reveals that the maximum height reached is 66 feet. If my Frisbee is 35 feet from the ground, will you hit it? We know that we will hit it because our maximum height is 66 feet. If you wanted to determine when you would hit it, you could substitute 35 into your equation for the height and solve the quadratic. In order to solve it, you need to subtract 35 from both sides so that your quadratic equation equals 0, and then you could use the quadratic formula again. We can go back to our graph and double check our answers. And again, we can see that at a time of 2, we have a maximum height slightly over 65, which is 66 feet, and our rock hits the ground after 4 seconds. You can see that the negative 0.0625 would be over here if our parabola was extended. This video has shown you how to interpret questions about scenarios modeled by quadratic equations in order to apply what you know about them and how to solve them.